So this is the setup for Joules Law experiment. So what we have is we have a thermometer over here. We have our ammeter, which will measure to 3 decimal places of an amp here. We have a graduated cylinder to measure accurately the amount of water that's going in. So in this case we are using a 50 ml graduating cylinder, so we're using 50 ml of water each time. Our stopwatch is up here, and our rheostat, which controls the current that flows through the circuit, is here. This is our calorimeter, which has the water in it and a heating coil at the bottom. So what's basically happening here is you have current flowing through this coil. You're measuring how much current that is, and you're able to change it with this. And you're using the thermometer to measure the change in temperature that occurs over a set period of time. The time obviously is measured with your watch here. So what we're going to start with is we're going to start by putting half an amp of current through this for 5 minutes. We measure how much the temperature increases in those 5 minutes and note that. And then we increase our current to 1 amp. And then we allow the current to flow through the circuit for 5 minutes with 1 amp flowing. And again we measure how much the temperature changes within those 5 minutes. So what you're basically doing is you're changing the current and you're seeing how the temperature changes with different current. So the important thing here is that you are keeping the same amount of water each time, that you're starting the heating with the water at roughly the same temperature each time. Okay, so that means we're going to replace the water at the end of each run. So the first thing I'm going to do with this is to set the current. So I'll switch on my power supply here, and I want half an amp. Now we're very close to that here, but you can see the reading there. You might have any reading on this at the very beginning. So what you're going to do is you're going to adjust your rheostat until your current is exactly, very close to, should be exactly at half an amp, at 0.5 of an amp. So that when you turn on, so there it is, it's at 0.5, that's okay. So we're going to be exactly, when you turn on your current, half an amp is going to be flowing straight away. So this is the thing that you do before you start the experiment. You set the current, then you take out the water that has been in there, okay? Because that has got heated ever so slightly. And what you're going to do is you're going to measure in 50 mils exactly from the tap. So the water coming from the tap should be roughly the same temperature all the time. 50 mils goes in here, and put my thermometer in. Okay, so let that settle, give it a little stir, and give that 30 seconds to settle. So that's settled, 30 seconds, and even maybe 10 or 15 seconds is fine, but just you have a temperature, starting temperature of 23.5 degrees. So that's going to be your initial temperature. So I have a little board here, but you'll do this in your copies of where I'm keeping track of your current. We'll do the current squared afterwards, T1 and T2. So the starting temperature and the final temperature. Subtracting those two allows you then to get the change in temperature. So T1 here is 23.6 degrees. Okay. Now, this is the important bit. You have got to start your timer and your current at exactly the same time. So let me make a bit of space here so you're able to see. So I'm starting the current and the timer at the same time, and I'm going to allow this 0.5 of an amp to flow for 5 minutes. So 3, 2, 1, go. Now, that's flowing 0.5, and I know that because I had already set the rheostat so that 0.5 of an amp was flowing. Now what you want to do during this experiment is you want to make sure that it is as close to 0.5 as possible, that if the current starts to change, and that will happen as the coil in the water heats up, that you're able to adjust that down. Now I've gone to 3 decimal places here, so I'm happy enough with that at the moment. And we allow that current to flow until your timer reaches 5 minutes. Okay? All the time keeping an eye on the current and making small adjustments to the current with the rheostat to make sure that that current stays at 0.5 and doesn't change from there. So 1.5 minutes through, and again just making very small adjustments to the rheostat to keep the current at 0.5, as close to 0.5 as you can. So there's going to be some fluctuation here, and sometimes there's very little you can do about it. Of course, the other thing to make sure that you do is you stir this throughout the experiment to make sure that the warm water and the cold water mix together and that you're getting the warm water moved around. So the reading on the thermometer should be the reading of the whole water, the temperature of the water as a whole, as opposed to being the temperature of the water down at the bottom, which is the warmer water. So you just keep that stirred. Okay, so we're coming up to our 5 minutes here, and once your 5 minutes are finished, you make sure you stop the timer exactly at 5 minutes. Or you stop the power, I should say, the current flowing. And for the next 30 seconds, or even 15 seconds, just to allow that heat energy to come out of the coil, the last of it, and go into the water. And you are just going to give that a stir, and you take the highest temperature that your thermometer goes to. So that's sitting at 25.1. It's not, there you go, 25.2. So you can see that sometimes it takes a few minutes or a few seconds for all the heat energy to work its way around. So I've moved the thermometer around there as well, and it's gone straight up to 25.5. So this is the key bit, making sure that you are actually getting the highest temperature of the water there. Okay. So 25.5 was the highest temperature. Sorry, 25.5, and that's what I'm going to put down over here. Okay, so I put down 25.5. So working out that, 23.6, 24.6, 25.6, so I've got a change in temperature of 1.9 degree. Okay, I squared is 0.25, and that's all right. So once I have that table completed, what I'm doing is you're doing a graph of I squared versus delta theta, and that should give you a straight line, and that then is going to prove Joules' law. So the important thing with this is that you are squaring the current. The current has to be in amps, and so it is not I versus delta theta, it is I squared versus delta theta, and your change in temperature, that's just degrees. So it's degrees Celsius, or if you want to be fancy, you can do Kelvin. Just don't do Fahrenheit. So that is the experiment, and the graph, I will put up a follow-on just to show the drawing of the graph afterwards. Okay, thank you.